Hi. Undoubtedly, this blockchain project has become a full-on cryptocurrency at this point. There's wallets and transactional data stored on a distributed ledger. There's a proof of work system to demand computational power. There's cryptography and data hashing to protect the system against abuse. However, there's still one final piece remaining, and that's the validation of transactional data in the blockchain itself. We have a lot of the pieces necessary to do this, but there's a couple more aspects to add before we can be confident that any incoming block of transactions can be trusted. We already have the method to verify that a blockchain array on the whole is just fine. The hashes and the difficulty for each block in that chain are verified. But we need to make sure the transactional data field itself follows the rules of our cryptocurrency. To enforce these rules, we're going to add a new valid transaction data method to the blockchain class. So in the blockchain/index.test.js file, let's add a new section for a new method called valid transaction data. I'll go ahead and collapse the previous methods, and this one is going to be called valid transaction data. All right, cool. And for these group of tests, we're going to need transaction data. So first up, I'm going to make an initial transaction. There's also the reward transaction to test as well, so make sure to have a reward transaction variable. And finally, to create all of these, we need a wallet, so add a wallet variable as well. Then before each test, we're going to set new instances to the relative classes for each of these. So first up, we're going to have the wallet, which is a new instance of the wallet class. The transaction is going to be the result of calling wallet.createTransaction. And for this, the recipient can really be anyone. We don't care about the recipient in this case, so how about foo address? And the amount can be anything as long as it's valid. 65 seems like a number that seems great to use at this moment. Then we have the reward transaction, and this is a static method from the transaction class that has a minor wallet specified in an object. And let's award this wallet itself. So overall, we now have a wallet, a transaction from that wallet, as well as a reward transaction for that wallet. Cool. Notice though that we have dependencies on the wallet class as well as the transaction class. So at the top of the file, let's import both of those. So first up, we need to require the wallet. So let's require it from the wallet directory, which is located at the default index.js file. So all we have to specify is /wallet. Likewise, we have the transaction, which is also located in the wallet directory, one directory back at the transaction file. All right, then we can head to our tests. And when it comes to the valid transaction data method, there's two overall situations to cover. One, when the transaction data is valid, and two, when the transaction data is invalid. Let's start by describing the situation where the transaction data is valid. And in this case, our function should return true to represent that. So our it test says it returns true. Okay. Immediately in this test, we're going to add a block to one of the chains. And let's add it to the new chain instance. The idea is that we want a main blockchain instance to check that another chain from a separate blockchain is valid according to its transactional data through the valid transaction data method. Therefore, it's more appropriate to add a block consisting of the transactions to the new chain variable. However, we need to confirm whether new chain is available to all tests. And if you scroll to the top, indeed, new chain is there for any test to use within the index.test.js file. Now this allows us to specify a data field in here, which is going to be an array of the transactions. Let's include the base level transaction as well as the reward transaction. All right, cool. Now we have a new chain that consists of some transaction data within its history. Now we're going to use blockchain, the main blockchain, to call valid transaction data. We're going to pass in an object that contains a chain field that is mapped to the new chain.chain. Now, normally we'd use a static method, but in this case, this is going to be dependent on each local blockchain, because when we enforce that the input balances are correct, we need it to be based on a blockchain history. and we can't rely on the incoming chain's blockchain history. We have to rely on our own blockchain history to make sure that the new one is valid. Overall, we're going to expect this return value to be true when the transaction data is valid. Okay, nice. Now we get to the invalid cases for transactional data. And there's 4 main rules that we have to enforce. So overall, we're going to capture all of those rules by describing a situation for each one. And the first rule is that the transaction data shouldn't have multiple rewards. So we're going to describe a test case where it does actually have multiple rewards. So our description is, and the transaction data has multiple rewards. And in this case, it should return false instead of returning true. So that is the if statement for that. The second rule is that the transaction data should be valid when it comes to its outputs, meaning it shouldn't have any malformed output maps. None of the output maps should have weird values to try and give recipients too much or too little currency. Therefore, we're going to add a test case where the transaction data has at least one malformed output map. So let's describe that. And the transaction data has at least one malformed output map. Okay, cool. Now, there are 2 further subcases where a transaction could be invalid when it comes to its output map. First, the transaction is a regular one, and the second one is where the transaction is a reward transaction. So first, we're going to describe the situation where the transaction is not a reward transaction. Okay, cool. And then, of course, we have the second case where the transaction is a reward transaction. Reward transaction. All right, cool. And in both cases, we should be returning false. I'll go ahead and copy this if statement to speed things up a little bit. So it should return false in both cases. After all, both the output maps are invalid. Okay, rule 3 now. The transaction data shouldn't have a malformed input either. So this is to prevent a situation where the input is trying to make a balance that is too high. And with this rule, we're going to enforce that the input balances are based on the blockchain history. So let's say, and the transaction data has at least one malformed input. And in this test, the function should return false. I'll paste that in as well. The last invalid case and the fourth and final rule is that the transaction data has been included multiple times within a block. So we're going to make sure that the block doesn't contain multiple identical transactions. In other words, we're enforcing a rule where the transaction data array has to be a unique set of transactions. And a block contains multiple identical transactions. Nice. And the result is that the function should return false. All right, so let's fill in the first invalid case where the transaction data has multiple rewards. In this case, we're going to add a block to the new chain with a data field that consists of an array of the transaction and then the reward transaction twice. So this is going to be bad. Therefore, if we call our previous setup where we try to validate the transaction data of the new chain based on the existing original blockchain, this should return false. Okay, for the second invalid case, we have one where one of the output maps should be malformed. And in this case, it's a regular output map. So let's modify the transaction.output map and change the amount for the wallet.public key and set it to something great like 999,999, our favorite invalid number. Or at least my favorite invalid number for whatever reason. It's probably because it's just one close to a million, so it's a somewhat cool number to see. Anyways, that's a huge tangent. But we're going to follow up and add a block to the transaction that consists of a data field with this transaction and the reward transaction. But the real transaction that is bad is the regular transaction, since its output map is now malformed. And likewise, we're going to expect if we call valid transaction data on this, indeed, it's going to be false. Okay. As for the other scenarios, we're going to fill those out in due time, but this gives us a lot to focus on already. So since we're in test-driven development mode, Let's run the test suite first before taking any further action. So let's go ahead and run npm run test. And as we do so, we should find a couple new errors in our console. And indeed, first up, valid transaction data isn't even a function, so we're going to implement that next.